The next concept we will do is equilibrium of forces. And Lamis theorem. So what is this equilibrium of forces and Lamis theorem? So equilibrium of forces means the net force is zero. Equilibrium of forces means net force is zero. Net force is zero, or in other words, we can say forces are balanced. Forces are balanced. So what will happen in this case? If F is zero, then acceleration will be zero. So system is not accelerated in this case. Okay. Now we will see what is Lamis theorem. So how it is related with this concept, and Lamis theorem we will discuss. Lamis theorem. So if we have three forces, suppose we have three forces, then the three forces will be in equilibrium if, suppose we have three forces acting on an object. Suppose these are the three forces acting on an object. This is F1, this is F2, and this is F3. And F1 angle in front of F1 is, this one is alpha, this in front of F2 is beta, in front of F3 is gamma. Then these three forces are in equilibrium. F1, F2, and F3 are in equilibrium if F1 by sine alpha equal to F2 by sine beta equal to F3 by sine gamma. So this much we can write. So this is the Lamis theorem. If three forces are balanced, then we can write this as the this will be the expression. This expression must be satisfied. And from where this is coming? This is coming simply from two concepts. One is the triangle law of vector addition, or the vector addition law, plus the sign rule of properties of triangle. So these two, if we combine, then we are going to get this. So how do we relate this? If you displace these three forces and if you try to construct a triangle like this, means F1, F2, and F3. If you construct this, the F1 is going to be, see the alpha which is appearing here, the F1 is going to be here. The angle between F2 and this F1 alpha is what? The angle between F2 and F3. So this is F1, this is F2, and this is F3. So angle between F2 and F3. So we can say like this. This one is alpha. This one is alpha. So from where this, if these three are making the closed triangle, then the net forces are zero. And in that case, this one will be, this one is alpha, this one will be gamma, and this one will be beta. So if these three are forming a closed triangle, then the forces are balanced. And in this case, we can write the angles according to sine rule. We can write these angles. This is suppose theta 1, this is theta 2, and this is theta 3. From sine rule, we can write F1 by sine theta 1, F2 by sine theta 2, and F3 by sine theta 3. So this we can write for three forces and three angles, three internal angles between them. So we can write according to sine rule. If three forces are making a closed triangle, and the theta 1 can be replaced with alpha, so we can write sine 180 the theta 1 will be how much? The alpha is equal to sum of these two angles. Alpha is equal to sum of these two angles, and theta is how much? Theta is 180 minus theta 2 minus theta 3. So this 2 can be replaced with alpha, or you can directly write. You can directly write like this: f1 by this much, then f2 by sine 180 minus beta, and f3 is sine 180 minus gamma. And 180 minus beta, 180 minus alpha, if you write these things, are going to result into simply sine f1 by sine alpha, and f2 by sine beta, and f3 by sine gamma. So this is proof of the Lamis theorem. This is proof. How it is proved? Because three vectors, if they make the closed triangle, only in that case we can say the three forces are balanced. So this is proof. If these three forces are making closed triangle, then these three forces are balanced. So three forces, F1, F2, F3, are balanced, then they make the closed triangle. And if they make the closed triangle, then we can apply these rules. So we are going to write these rules, and this is the Lamis theorem proof. So now we will see application of this.